Hey guys, welcome back to my channel. So today we are going to discuss garbage collection. So we will be discussing mark sweep compact and generational garbage collection. So for that we need to understand memory management a bit in Java. So we have stack and heap, okay, and all the methods and the variables and the object reference that are stored in stack and all the objects that are newly created with the new keyword are stored in heap memory, okay, and allocating that new memory for the particular object and deallocating is the responsibility of the JVM, okay. And garbage collection is important because we have to create so many number of objects and we have to allocate space for that, and definitely resources are expensive and that needs to be managed properly so that we can keep accommodating new objects, and the ones that are not required, they should be removed, and the cycle should go on like that, right? Because if we are not removing the unreferenced or the unused objects, they might create memory leak, and eventually we would face out of memory error because there would be no space. And in order to save us from that space crunch or the resource crunch, we would require a help, right? So garbage collection is something initiated by the JVM when it feels that it is required to do so, and we can't do it manually. But in some of the languages like C++, it's the responsibility of the developers, and that opens the gateway of memory leak. I mean, there might be a possibility because this is such a important process, and handling it manually might cause problems, right? So, yeah. So when we are talking about memory leak, there are certain things that can be done so that we can, as developers, avoid the memory leak. That is less use of static keyword, because static, by defining something as static, we are saying that it has a lifetime until the application runs, right? So it will definitely occupy a huge space, right? As you can see in this code snippet, we have a static list, and to that we are adding a huge number of doubles, right? So if that stays along the lifetime of the application, you can imagine how much space that is gonna take, and would definitely like create a memory leak. Other reasons are unclosed resources. You need to close the resources which are opened up, because again that would create a memory leak. And improper equals and hash code implementation. So in map, you know that we have to implement the equals and hash code method so that the new created objects are differentiated, as they would have a different hash code if implemented properly. If not done so, then the same objects would be created again and again, and over the time that would create a memory leak. Also, we should understand that we have to use soft references instead of strong references, because like if you are creating strong references, then it's little difficult for the garbage collector to collect memory, or like reclaim the object, right, and release the space. But if you are creating soft references, or wrapping up a particular object with soft reference, then whenever there is a possibility of memory crunch, and before giving out of memory error, the JVM would reclaim those objects and would be able to free the memory. Okay. Now, garbage collection gives great benefits to high level language and also prevents a lot of errors in housekeeping, because we don't have to do that. JVM does that for us, and it is run by a background thread, runs at an predictable time, and forces application to slow down. Okay, so we can't initiate garbage collection. There are methods system.gc and runtime.gc, but those are not recommended. And also JVM won't run according to like when you request it, but only when it feels the need to do so, right? And about application slowing down, That is like when we are running a full garbage collection, then stop the world happens. That is the application like shuts down so that no new objects are created, and none of the objects which are unreferenced are unreachable. So all that happens. So let's talk about the basic garbage collection now. Mark, sweep, compact. So whenever there is memory crunch, the heap memory will be like scanned and it will be marked. So like all the live objects won't be marked, but the ones which are ready for garbage collection, they will be, or like unreferenced ones which don't have any uh, live thread association with to them would be marked, and the objects that have no reference, they will be removed. Okay. And sweep is like all the unreferenced objects are recycled from the heap. And while doing so, you would see that there would be fragments of memory, like fragmentation would occur. And in order to make it more compact and have a contiguous block, compact happens. So marked, sweep, and compact happens. And this process can be really time consuming and might slow the application. So this does not happen always. Okay, because the lifetime of the objects are relatively small. Okay, and that can't be happening again and again because mostly we are dealing with short-lived objects. So for that we have generational garbage collection. Okay, this handles the short-lived objects very effectively. So heap memory is divided into young generations and old generations. So the GC which happens with the young generations is called minor garbage collection, and the GC which happens with old generation is called major garbage collection. And when a full garbage collection happens, that is called a full garbage collection, and also the compacting happens. Okay. So let's look into the young generation or the minor garbage collection. So all new objects are initially allocated to the young generation, and it is divided into or partitioned into two space, that is Eden and Survivor. Survivor is further partitioned into SO and S1, that is from space and to space. Now, whenever the Eden space or the Eden partition fills up, JVM launches minor garbage collection. Okay, so what happens is the live objects are marked and moved. Okay, to like one of the survivor space. And again, when the garbage collection happens, again the live objects are marked. The Eden becomes empty if it was filled from before, and then the live objects are marked in SO, and SO becomes empty, and then it is shifted to S1. Okay. Again, next time when garbage collection occurs, the live objects are marked. Eden becomes empty, and objects are moved from S1 to S2, and they contain objects, and it's from S1 to S2. So in SO, like we have objects that have different ages. So what I mean by ages is that if a particular object is surviving X number of garbage collection cycles, so its age is X. Let the age be 8. So that means that particular object has aged and it has survived 8 garbage collection cycles. So in that case, that moves to the old generation, and then the mark, sweep, and compact happens for those because they are relatively bigger objects and they have aged. And so for minor garbage collections, that happens only between Eden and Survivor, but the major ones that happens with the old generation only for objects that have aged. Okay. Now, full garbage collection. It cleans up both the young and the old generation, and it promotes life objects from the young generation to the old generation and compacts old generation. A full garbage collection stops the world pause. So application stops and becomes unreachable, right? And as I mentioned, we can ask the JVM to do the garbage collection, but it depends on the JVM. It runs at unpredictable times and forces the application to slow down. Okay, so this was a short, not relatively short, but like a summed up knowledge of garbage collection. So, hoping you understood this. So, thank you so much for watching, and let's catch up in the next video.